Okay, I am going to do a short stream. A stream because there's been progress on our card game, and I do want to stream as often as I can. Short because I've been doing stuff all day, and honestly, this is the best I got. So it'll be short, but it'll be good. I promise. Let us talk about what has been happening. I have been working for, well, this is technically the seventh day of working on a card game, but I have to be straight up and say I do other things. I can't work on this full time. And it's fun anyway. It's meant for fun, so it's not really meant to be. I guess what I'm saying is I'm okay to do it incrementally. And so there's been a little bit of progress. The game is a card game. It'll be as if we're playing cards. So you have two players, player one, player two. They'll have cards in their hand and they'll decide which cards to play. These cards, like card battle games do, they have stats on them and they'll have some pretty picture. Right now they're just silly names and some stats that we made up. We have power, defense, speed, health, and luck. At first, they were just names, but we've decided now exactly how they translate into a battle between two cards, such that speed determines who goes first. Oh, I'm sorry. I think we're listening to I tend to have Twitch streamers on in the background, and I'm listening to Gerbifer. And one day I hope to be able to raid her. That'd be fun. Pardon me. I'm sure that was going through to my feed too. Anyway, let's talk about two cards battling each other. These stats translate into speed, which is a rating from 1 to 10, where speed will determine who will go first. Between two cards, one of them will go first based on speed. Then, the one who's attacking the other, you'll take their power and subtract the other's defense. This differential will determine how much health is being delivered to the defending card. And then they go back and forth. So in a two-play or two-card matchup, in a two-card battle, this is relatively straightforward. I can take the speed, figure out who goes first, and go back and forth. I can do the power of one minus the defense of the other and subtract hit points that start at the health rating and then go down until one of them is defeated. About the time that one is about to be defeated, we do use luck as a potential rare chance that they could turn the battle around, and instead of dying, they win the battle. Okay, that's what we got. And we've been making progress on this. We have a prototype of two cards battling, but that is not enough. We know that's too simple. We want multiple cards going after each other. And so it might look something like this. There could potentially be a situation where it's not just two cards versus one, but maybe even three versus two, or who knows, five versus five. I mean, who knows? It would be great if we had a system of working with these stats and the cards such that we could determine, I don't know, 25 versus 25. I mean, how crazy would it be to put the whole deck against each other and have a huge battle royale? That'd be fun. Not that that's part of the game, but we know one card against one card is far too simple for these brains to chew on. And so we would rather figure out what it's going to be like when multiple cards battle against each other. As these arrows sort of indicate, it's possible that, this card would do well against that one, but this card might also do well against it. And so who goes first really matters. This speed is no longer between two cards, it's now between multiple cards. This is the step I was focusing on. Previously, we're working on something called shiftables and shiftable space, so we could do formations and things. But right now, it's who goes first. That's actually the problem we're going to deal with now, because if, excuse me, if we have two cards going against each other, it's one thing. It's basically like going back and forth. But if we have multiple cards, say 5 like this, then it's really more like an order, a sequence where a card has its turn before the next cards and so forth. So among all the cards, for example, they are actually laid in a sequence. And maybe this works out great, but what we actually need to do is read the speed values of each of the cards and determine who really goes first. This is meant to manage the chaos between multiple cards. However many cards it is, it could just be 2 versus 1, but I would like to go ahead and develop a system that could handle more, frankly, because we may decide it's more fun to have cards that are bigger battles. So if that's true, and we look at the speed of each card, then it probably doesn't just line up like that easily. It's probably more based on the order of the speed, and we need to know this order. We're going to call it the battle order. So we know when cards do join in battle between each other, we know who goes first. So far in our discussions about this card game, we've only anticipated one situation where this matters, where one card battled another in the beginning and one of them won. And now it can help its neighbor to join in battle against its foe. And so there's actually just 3 cards in battle. So right now we're really only concerned with this situation where there's 3. But it could be that we want more. And like I said, I want to actually engineer this a bit more. So what this is called when we have an order that we want to place based on these values, like speed, where the highest speed value, 10, it has to go first, and the lowest speed value, in this case 2, has to go last, and it needs to be ordered. This is called sorting. And a sorting algorithm is a very common programming challenge to deal with, and we're going to pursue one called a insertion sort. There are other sorting methods. It's a hot topic in programming terms. But let's talk about how this insertion sort method works, because this is what we've got. This is what we've been working on so that we could perform combat between multiple cards. We have a number of cards to put in this order, this battle order, and we want to look at the speed value of each card and then reposition it so that the highest speed card is in the front and the lowest speed card is in the back. Even if this is going back and forth between player 1 and player 2's cards, we need to order all of them that are currently touching each other and ready to battle each other. So an insertion sort works like this. You are going to go from the beginning to the end and look at each of the ones that are there. And let's just say for arbitrary initialization sorting situations, it would be ordered. But this card may actually have a speed of 7. This card may have a speed of 10. This card may have a speed of 2. This card may have a speed of 5. The way that an insertion sort works is you start at the beginning and move on, but you actually are comparing 2 at a time. You are comparing 2 and deciding if this one is in the proper order as compared to that one. In this case, we want this one to be more and this one to be less. Okay, so we compare 2 at a time. We're here, and this one is a 7, this one is a 10. So actually, this is not the right order. If that's true, we plan to switch the 2. So we compare 2 of them and decide if it needs to switch. In this case, it does. And now there will be a 10 in the front and a 7 in the back. The next is, 2. I'll just keep track of this while we work on it, just to demonstrate. I'll call this one 9. Now we continue on the path. We're comparing the next two. Here's where it gets interesting, because we've set the order correctly for this beginning of the series. Now we're on the next two, and we're looking at these. Right now this is 7 and 2. We want the bigger number to be on the left and the smaller number to be on the right. So this is fine. This means we can move on. So we continue, and we continue, and we look at the next two. The next two would be these two. And so now we're looking at 5 and 2. And we're looking to make sure that the number on the right is smaller and the number on the left is bigger. That's actually not the case. And so this is a case where we, again, want to switch. Okay, so now we're going to switch 5 and 2. 9 is back here. And the 7 and 10 haven't been messed with yet. But the key with the insertion sort is that after we have adjusted this and made a switch, we now go backwards. And we now look at these two again and see if this is still true. In this case, is 7 bigger than 5? And the answer is yes. And then we go back to the beginning. Is 10 bigger than 7? The answer is yes. Okay, cool. So we're ready to continue on. There's two things going on. There is the moving forward through the array. And then there is the comparison between pairs that will go backwards. And this process happens every step of this progression way, so that the beginning of the array is sorted properly, and then as you progress and potentially switch things, it will go back and ensure that the beginning is still ordered correctly. So at the end here, we're comparing these last two numbers. As you'll see, this now is looking to make sure that the one on the right is less, the one on the left is more, and that is not correct. It needs to switch. So now this would be what? 2 and 9 and 5 and 7 and 10. And as this now continues to go backwards and check the pairs to make sure they're in line, this 9 is going to continue to be switched and switched all the way up to here. And at the end of that process, we have ensured that it is all ordered correctly. And the end result would look something like this, which is exactly the order we want. The insertion sort method has some advantages. It is relatively fast, but it's also, compared to other sorting methods that are faster, it's actually less complex. This two parts where you go forward through the array, but then each time you just compare two and work backwards once you have switched, is really as complex as it gets. Anyway, that's the idea of an insertion sort. And what I wanted to be able to show is how that looks when we actually see it in the code that is handling it. First of all, this is the old data that we used to make our test work. We had an old test between two cards. And, those work fine. It looks cool. We were able to play with the idea of adding some visual effects and some camera shake and stuff, and so it's kind of fun. But we know that two cards is too simple. So we will abandon that test, taking the good stuff that we got from that, and move on to this test. The old test used this data. We knew we were just using two cards. So it was easy enough to say, is it player 1 that is going first, yes or no? Because there's only two cards there's only two possibilities. This is pretty easy to deal with. And I only worry about one card on each side. I only worry about tracking one card's health as the hit points are reduced, and that's it. Well, there is some things that are still going to be the same. The battle will end at some point, and either player 1 will win or player 2, but the rest of this, frankly, changes. So we made new data. Now I can hold as many cards as I need on either side. For both player 1 and player 2, you could have one or more cards. This now is the battle order. It is actually holding numbers, a series of numbers, where each number is pointing to some card here in this hand or in this hand, or the play, I should say, because these are stacks of cards laid on the table. So while it may start out that each of these numbers in the series is like sequentially describing each card that's on the table for both hands, just simply 1, 2, 3, 4, 5, 6, we need to actually order this based on speed, and that's what we're going to do with our sort. But to continue with this data idea, we are still tracking turns because each card now has its own turn. And each card has its own hit points, so I need to keep track of all those. But like I said, the battle will end still, and either player 1 will win or not. So that's still the same. But we've refigured the data to handle more than one card, which is great, because while this was our old script that handled just 1v1, now we can handle more than that. Because while we still have a deck of cards and the player 1 and player 2 have 5 cards to draw from and play on, now they can play as many cards as they need to, and we can test this battle. This can have multiple cards battling multiple cards. Here is that data we were just looking at here. Here. It is ready to be used in this test script. There's some of the other variables we were using before. Like I said, I copied most of this from the original test. So that includes some of this battle configuration and the battle progression we also copied from the original script. Some of this actually looks the same. We use some helper scripts to set up the battle and configure the cards that were played according to what the player wanted to do, player 1, player 2, and set them into that battle data. The battle order now starts out as simply an empty string of numbers, but we're going to work on that. And the hit points are set based on the health of the card, the health rating on the card. And the card, so these card hit points are being already set up and everything. Okay. We are going to have all the good things we had in the 1v1 battle here in this larger script that's testing more bigger battles. Some things I am skipping for now because I frankly wanted to make sure that we could get to the tests that we need to do. So doing something like configuring representation of these cards in the display, that's lower priority. I'll come back and do that later. I'm okay to skip that for now. What I'd rather do is deal with this battle order. So that's what we're doing here. As I mentioned before, it's just an empty string of numbers, and I just fill them with 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, 5. So that however many cards there are, they just have some number associated with them that refers to the cards that are actually laid on the table. Some for player 1 and some for player 2, however many there are. Now, this routine is meant to order those cards based on the speed rating of those cards, like we were describing. I go through the battle order starting with 1. Actually, I leave 0 because I'm actually going to compare 1 and 0. That's the pair that I'm going to compare. And I'm going to go up all the way to the end. While I go all the way up, I'm going to use that number to reference the actual speed. I did another helper script to grab the speed of each card just based on the index that it's either coming from player one's play or player two's play. And I just need a helper script to grab the attribute, in this case speed, but I could grab anything from this helper script. So I grab the speed of both cards that I'm looking at, the pair that I'm looking at. And in the beginning, it's going to be 1 and 0. But as I go up, it'll be the next pair, etc. If the comparison is that actually it says A, but A is actually the later card. I guess that's a little confusing. If that's greater, then these should actually switch. In other words, in the first instance, position 1 has a greater speed than position 0. If this is true, then we should switch. This routine does a switch. It says make a temporary thing, have it equal to the latter one. Make that latter one equal to the earlier one. And then make the early one equal to the temporary. This is a way to sort of switch two things around. Cool. If you recall, there were two parts to the insertion sort. One was going through the array. The other was going backwards and checking each pair to make sure everything was still in order, even after you switched. That's what this is. This starts at wherever we are in the progression of the full battle order. But after this comparison and after we switch, we go back. And while that is we're not at the beginning, we continue to go back and back and back. And we continue to compare the speed of the two cards in the pair, to do this check and make sure that it is actually in order. If not, we switch again and we continue to go backwards. This way, we are ensuring that the earlier parts of this battle order is always in order. In this case, we want the largest speed in the front, the slowest speed in the back, whether it's from the player one's play cards or the player two play cards. And just to confirm that this is actually working, I go ahead and print out the results so we can see it. And the rest of the script isn't exactly there yet, but I have filled in some pieces, again, copied from the original test. So there's still more to do. But this is a critical step. In order to get multiple cards to play at the same time, this new test script still has 40 cards. We've already dealt 5 to each player, and I'm exposing the first 3 here in player 1 and the first 3 here in player 2. I'm just automatically picking those first 3 to play. It's kind of we're not actually playing yet, so I just really want to make sure that the mechanism works, and so I'm just picking the first 3 on both sides. And then I can test it with this little checkbox. So when I do test it, it's not showing up here. It is instead printing out, as you saw in the code. This is telling us that the sort was complete. That's what this code is. And that it starts with this card with a speed of 10. Time Pony does have a high speed, and it wasn't in the first position, but it was sorted to be there. And then this other one, Coffee Badger, happens to have a speed of 9. Well, that's actually from player 2's hand. Player 2 played Coffee Badger, there it is, with a speed of 9, and so it's actually going to come next. So right away, we're seeing player 1 has a card that's going, and then after that, player 2 has a card that is going. So all these cards are playing all at once. They're all battling all at the same time, kind of a big skirmish. And in that skirmish, these 2 cards are going first. And then comes this other one. Yes, Growth Serum is here. It's got a speed of 8. That's player 1's card. The final bullet is player 2's card, interestingly. And so it is sorting these properly in order, the battle order is now set 0, 1, 2, 3, 4, 5. But the index of which card it's coming from has come from which card is being played by which player. And so we can actually have multiple cards now begin to battle because we know who's going first. So that is where we're at the moment. We have more to do on this card battle game, but what we were able to do is make multiple cards work, and that is the next step. As we progress in this design and development of the card game, we find next steps that seem most important. And at this stage, it often has to do with what is the step that's going to allow us to answer the next most important question. Design often has questions that relate to what is going to be a better player experience. And one of the things that we decided early was that the simplicity of one card versus one card was going to be a problem. At least it wasn't going to be as good as having strategy and tactics that could come from picking more than one card, potentially having more than one card in battle at the same time, if not a sequence of cards going into battle at different times and potentially helping each other. In fact, what this step represents, being able to sequence any number of cards to go into battle, what this represents is a way for us to then go in and test a bunch of completely different ways in which the battle could be, how do I say this? We can test different rule sets for how battles are played in our game. In other words, our game will end up being a certain way, but we don't know which way is exactly the best yet. And by coding up this stuff to allow multiple cards, any number of cards, to attack each other, similar to how we took some time to code the shiftables that we talked about last time, this allows us to play and adjust and experiment with completely different ways to structure the rules of the game so that we can actually do whatever we want. What I'm saying is we are about to get to a place where we can really have wildly different ways to play this card game and see which one is more fun. So, I hope that's enough of a short stream to be interesting, and yet I gotta go. So, if you enjoy watching an ape in a jungle trying to make games and want to participate in making a card game with us, please do follow and please show up next time we stream. Talk to you soon.